Alright, here's what the question says. The question says, in an agricultural experiment, the gain in mass of 100 cows during a certain period were recorded in kilograms as shown in the table. Alright, if you remember anything, you remember that statistics is the study and analysis of large quantities of data. So this is the information of the results from an agricultural experiment. This is what we call group data. Alright, in previous videos, I would have indicated that this is the lower class limit, and that this is the upper class limit. I would also Alright, so in this question, some things I must remind you of. For group data, as I said, this is group data, n is equal to the sum of the frequency. And if you should add this up, you're going to get what? 100. Why 100? Because it says, in an agricultural experiment, the gain in mass of 100 cows. Alright? So, in this question, the data that you're dealing with is gain in mass, and the frequency is actually what? Number of cows. So these two cows, the gain in their mass is from what? 5 to 9 kilograms. These 29 cows, their gain is what? 10 to what? 14 kilograms. Fine. Now the class midpoint. The purpose of the class midpoint is to deal with the fact, and I'm saying you guys should remember some of this from last year, is to deal with the fact that you do not know the actual values. Remember? All I know about these two cows is that the gain in their mass is from what? 5 to what? 9 kilograms. Do I know exactly how much each of them gain? No. All I know is that it's between what? 5 and what? 9. And group data presents a little problem. For example, a problem when you're going to calculate something like the mean, the average. In order for you to calculate average is the sum of all values divided by the number of what? Values. But we do not know the actual value, because this is from what? 5 to what? 9. I don't know the actual value. To fix that problem, they have the what? The class what? Midpoint. So rather than say that these cows gain between 5 to 9 kilograms, we say that the two cows gain what? 7 kilograms. Each of the two cows gain 7 kilograms. Is that the truth? No. No, it is an estimate, because we do not know what the actual value. Alright, the first thing we're asked to do, copy and complete the mid-interval values column. So they want us to complete this. Here's something you should notice. The mid-interval values are the class midpoint. It goes up by a fixed amount. Look and tell me how much is going up by. It goes up by a fixed amount. How much is it going up by?
5.
It is going up by 5. So the next one would be what? 22. The next one after that would be what? 27. The next one after that would be what? 32. Ladies and gentlemen, the mid-intervals value goes up by a fixed amount. Next, B, I says, calculate an estimate of the mean gain in mass of the 100 cows. Calculate an estimate of the mean gain in mass of the 100 cows. So this is B, I. The mean x bar is equal to the sum of fx divided by n. Now, some things that I said, the fx is frequency times class midpoint. What else? N stands for what? Number of values. Now, the sum of fx, is an estimate of the sum of all values. Let me ask a question. How do you calculate average? Because another name for the mean is the average. So we're asked to find the average gain in mass of the 100 cows. How do we calculate average?
Everything that you divided by 1.
You have to add up all values and then divide it by the what? Number of values. N here stands for the what? Number of what? Values. So the top piece must stand for the what? The sum of what? All the what? Values. So the sum of fx is an estimate of the sum of what? All values. Why did I say an estimate?
Because you are sure.
Good. Because the values I use in it is the what? Class midpoint. The class midpoint is an estimate. So the mean I calculate using the class midpoint is also an estimate. So that is why anytime whenever you're doing group data and the examiner says calculate the mean, he'll always say calculate an estimate of the mean. Alright, so now the first thing I need to do is I need to put up a column called fx. So this is fx, which is frequency times class midpoint. So this is what? 2 times 7, 29 times 12, 37 times 17, 16 times 22, 14 times 27, 2 times 32. 14 here, 64 here. Can you help me with the rest of them? 29 times 12. And somebody with the calculations. Have a calculator? Alright, 29 times 12. That just means 29 times 12. 340 how much? 348. 37 times 17. 629. 16 times 22. 352. 14 times 27. 300 and? No, so 78. 378. If you add these up now, the sum of fx is equal to 1785. Can anybody again remind me, what does the sum of fx represent? I would have told you before that the multiplication is done as a shortcut for addition. How many cows weigh 7 kilograms? 2. So if you add up them two weights, it's 2 times what? 7, which is what? 14. So this is the weight of what? 2 cows. This is the weight of how many cows? 29 cows. And each of those cows weigh what? Talk to me now. So the multiplication is done as a shortcut for addition. This is the weight of 29 cows, the weight of 37 cows, the weight of 16 cows, and this is the gain in mass of what? The 100 cows. Ladies and gentlemen, the mean x bar is equal to the sum of fx over n. The mean x bar is equal to 1785 over 100. This is 17.85 kilograms. The mean gain in mass of the 100 cows is 7.85 kilograms. Alright? Next part of the question. Alright, now what we're going to draw next is we're going to draw a frequency polygon. Now, I want you to draw L-axis and use a scale of 2 centimeters to 5 units on both axes. Alright? Using L-axis and using a scale of 2 centimeters to 5 units on both axes. So these are my L-axes. And the scale is 2 centimeters to 5 units on both axes. What does that mean? Every 2 centimeters, the number goes up by 5. So it's 5. 1 centimeter, 2 centimeter, 5. 10. 15. 20. 25. 30. 35. I need to work a bit further. 40. Down here is going to be the class midpoint, which is still what? Mass in kilograms. Alright. Over here, same scale, 5, 10, 15, 20, 25, 30.
So you need to quantify them?
35, yes, I started. 40. Alright, over here is the frequency. And this, in this instance, this is number of cows. This is number of cows. So everybody draw the axes. Alright, so the two things we need to draw are frequency polygon. Your frequency polygon is going to look something like this. And down here is the class midpoint. And over here is the frequency. Alright. So those are the two things you need to draw your. While you prepare your graph sheet, I'm going to tell you some more things. I'll tell you that. Alright, so that's something that you should know, and I'll show it to you in action, that the frequency polygon starts and ends on the x-axis. It starts one class width before the first class midpoint and ends one class width after the last class midpoint. I will show you that in action. Alright. So the values, these are the points that you're going to plot to draw your frequency polygon. You're going to plot the frequency against the class midpoint. So it's class midpoint 7, frequency 2, 12, 29, 17, 37, 22, 16, 27, 14, and 32, 2. So these are the points we're going to plot. This is the class midpoint, and this is the frequency. Alright. Now, there's only one other thing you have to conquer. Down here, let me see if you remember anything. What is the value of each minor division on both axes? These small divisions. This is 2 centimeters to 5. What is the value of the minor divisions? Let me see if you remember.
1.5 right?
Every centimeter in graph sheet is divided into how many equal parts? Every centimeter in the graph sheet is divided into how many equal parts? 5. So 2 centimeters will be divided into how many equal parts? 10. 1 centimeter is divided into 5, so 2 centimeters will be divided into 10 equal parts. See it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this 2 centimeter, which represents 5 units, is divided into 10 equal parts. So one small division would be 5 divided by 10 equal parts. This is 0.5 units. So here, 2 centimeters is representing what? 5 units. But one of these little divisions is representing what? A half of a what? Unit. So this is 0. This is 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. Each of the minor division on both axes is what? 0.5. Stay with me. So let's plot our points. The first point is what? 7, 2. So 7 vertical and 2 horizontal. Alright, watch this. 7 vertical and 2 horizontal. So that's 7. 5, 5.5, 6, 6.5, 7, 7 corresponds with 2, 0, 0.5, 1, 1.5, 2. Alright, and everybody knows that you must not draw these dotted lines, right? I'm the only person who draws dotted lines. 12 corresponds to 29, So this is 10, 10.5, 11, 11.5, 12. 12 vertical and 29 horizontal. Let's find 29. 25, 25.5, 26, 26.5, 27, 27.5, 28, 28.5, 29. Then 17 corresponds to 37, 15, 15.5, 16, 16.5, 17. And that corresponds to 37, 35, 35.5, 36, 36.5, 37. Then 22, 22 corresponds to 16. This is 20, 20.5, 21, 21.5, 22. And that corresponds to 16, 15, 15.5, 16. Then 27 corresponds to 14. 27 is here. Corresponds to 14. 10, 10.5, 11, 11.5, 12, 12.5, 13, 13.5, 14. And lastly, 32 corresponds with 2. 30, 30.5, 31, 31.5, 32. And that corresponds with 2. Alright, I'm going to answer to this. Allow me to finish the question. Then I'll give you all the time in the world to finish writing up everything. After you put in the points, then you need to connect them. And remember, you must not have these dotted lines. You're going to connect them using a ruler. Connect them using a ruler, straight edge. Alright, it's almost finished. What we need to know now is what started and ended. Here's what I said. The frequency polygon starts and ends on the x-axis. It starts one class width before the what? First class midpoint, and end one class width after the what? Last class midpoint. Please look. How much is this going up by, the midpoint? How much is it going up by? 5. If it's going up by 5, which one will come after 32? It ends at 37. So let's find 37. 35, 35.5, 36, 36.5, 37. It ends at 37. Connected with a straight line. Now, it's going up by 5. If it's going up by 5, which one would come before 7? Talk to me. 2. So let's find 2. 0, 0.5, 1, 1.5, 2. It starts at 2. Connect them. This is what a frequency polygon looks like. As I said, let's give me a chance to finish it, and then I'll give you all the time you need to complete your drawings. Last part of the question. Absolute last part. Great question. Calculate the probability that a cow chosen at random from the experimental group gained 20 kilograms or more. Calculate the probability that a cow chosen at random from the experimental group gained 20 kilograms or more. Let me ask you, look at the table and tell me how many cows gain 20 kilograms or more? Talk to me. It's more than 16. But I know where you're coming from with the 16. How many cows gain either 20 kilograms or more than 20 kilograms? it is actually 32 cows. These 14 cows, how much weight, how much mass did they gain?
25 to 20.
Isn't that more than 20? These two cows, 30 to 34, which is also what? More than 20. So how many cows gain what? 20 kilograms or more than 20 kilograms? 32 cows. Out of how many cows? 100. So see, the probability that the mass, that the gain in mass is greater than or equal to 20 is equal to 32 cows out of 100 cows, or 0.32 or 32%. So there's a 32% chance if you choose a cow at random from the experimental group, that cow would have gained what? 20 kilograms or more than 20 kilograms.